Yes, sir.
So anyway, good evening. Okay, so I think we have as already I mentioned this, I will be discussing so three things, like one is the repair, then health facilities of Orissa, then Kedarnath I will show you. So I think the repair aspects I have already just briefed actually. Okay, so if you want to know more in details, say, of the repair techniques and others, I already mentioned you that textbook. Okay, the starting of my this one. Okay, the textbook contains very nice all the details. I picked up these figures also from the book itself. Okay. Now we will see this vulnerability of health facilities. Yeah. So now this we will be discussing. Okay, so this was a project which we did in 2014, 2015. Then I think it continued actually. Okay, for 16 and 17 it went up. So this was sponsored by UNICEF actually. Okay, United Nations, the children. This one. Then of course the Orissa State Disaster Management Authority. So they sponsored this project. Okay. So the main aim of this project was, so we have to do a rapid visual screening of all the hospital facilities in Orissa, including villages, towns. Means, I will show you that CHC, PHC, and other things also. And finally, we have to give the strategy actually, like which is the most vulnerable structure, and we have also to tell us the strategy how to repair that hospital also. So this was the main objective, of this project itself. Okay. And of course, this is not required here. So they want, as a part of this project, they also wanted to find out the risk also. So risk anyway is a famous formula, the hazard, exposure, vulnerability, all these things if you integrate, so you will get the seismic risk. So what they wanted was they wanted to find out this risk actually of this hospital building, and then to give in terms of all the details, and then which is the most vulnerable, so that to identify, and then which hospital they have to first repair it, how to the funds and other things was the main objective of this project. So now when it comes to the hospital buildings, I don't know how many of we have these documents actually, Indian Public Health Standards, so their documents are there. These documents are available in National Health Mission. Okay. The old documents are also there. Now these documents have been revised, I think 2022, the new versions are there. So these standards, they will give you all the details about community health centers, which is something like a big hospital actually. Then the primary health centers, okay. So what should be the primary health center, how it has to be constructed, how many rooms have to be there, all the details, architect, everything will be there in this standards actually. Okay, so you can download this in free, from our National Health Mission website. These things also. So as per this 2022 IPHS guidelines, say all the hospital buildings are divided into four categories actually. One is sub-district and district hospitals, they say. Okay, then we have community health centers, so they will be located in rural as well as urban. Then we have primary health centers also. Okay, and of course polyclinics, they will be located in rural, even in urban areas also. Then polyclinics, they say. Then health and wellness center are the sub centers actually. So they will be located in rural, of course urban, but mostly they will be in the rural areas itself. So as per our mandate, say, so the UNICEF told to do the vulnerability analysis for these three type of things only, that is CHC, PHC, and then SHC structure itself. So this is a definition of community health center. Okay. So it is defined, you can go to the public standards here. So it is CHC means in rural areas, say, like if we are having a population of 80,000, in hilly tribal areas, that means one community health center should be there. It is a mandatory actually. And if you take in urban areas, say if you're having, metro cities or whatever with a population of 5 lakhs, means you have to establish a CHC. And if it is a 2.5 lakh population, if there's a non-metro cities, you have to establish a CHC. So this is something like a definition. So if you are in a metro and million plus cities are there, say, so 5 lakh population and 100 bed facility, you have to make this CHC. So these are definitions. And this documents, our Indian Public Health Standards, it also contains, the architecture, like is how we have to construct, like, where the doctor room should be there, the surgery room, the nurses, and then, the pharmacy, and the dormit, the beds, say, how many beds are there. So all the details are available in this Indian Public Health Standards. Now coming to primary health centers, the definition is like this. So if rural primary health center means for a population of 30,000, say, you should have a rural primary health center. If it's a hilly and tribal areas, for 20,000 population, one this primary health center has to be there actually. So this is a definition of a primary health center, and you can see the population is more CHC, then the PHC will come into picture. There, so the details like the drawings, how the primary health center should look like, all those details are available. Doctor's room, pharmacy, everything is given in this guidelines. Now, when it comes to sub health centers, say, so for a population of 5,000, in villages or whatever, you should have a, this sub health center. These are like small, things itself. Maybe RMP doctor or somebody may be located here. So you can even construct in urban areas also. They say every 15,000, it should be like a specialized kind of things like, the slums or pockets also you can construct this sub center also. And of course, this is how a sub health center should look like. Lot of plans are there. If you want to go for 2-story, 3 stories, how you should construct these details available itself. Okay? Like you say, living room, doctor, all the details are okay. So these details are available. Okay, the drawings in this one also. What should be the built-up area? What should be the the size of this area? All the details are there in the Indian Public Health Standards. So now coming to the Orissa, say. So now Orissa, what happens is it has the most important disasters. Are the most important thing is the floods, then cyclones, storm surges. Of course, tsunamis are not a big deal, not so much important. But these are the three most important things in Orissa actually. And as already I told you, Orissa, the most important thing is it is located to the sea coast. Say. Obviously, corrosion is a huge, the chloride-induced corrosion. We say, okay. This is the most important thing, which has, thing which you have to, the main thing which is for repairs itself. And this is anyway the population of Orissa, and you can see the wind and cyclone zones of Orissa. Say. It is divided into some, the highest, I think, the seismic. So this wind zone will be near the coast, and as you go far away, the wind speed decreases also. So these are some of the cyclones in Orissa actually. Okay, like 1737, there was a super cyclone. The list, of course, you will get these details from IMD, the website also. You can get all the details also. So the most important, so the objective is to identify. Okay, since we are doing a hospital building, it is not only the structural component. The non-structural component also becomes important actually. Okay, and whenever the hospital building means, whenever there is a cyclone or a flood, so the hospital should function. So if they are not functioning set during that time, that means there is no use of that building itself. So the structural, non-structural, infrastructure, logistics, all of them are very important. See, like for example, the hospital may be fine, during a cyclone, everything may be there, but if the approach road is damaged, then there is, it's a waste actual. So this also has to be classified actually, okay. And then to identify the gaps, say the preparedness of the health systems, okay. Like whenever there is a disaster happens, how this health system is going to perform the preparedness actual, how fast they can take care of these the casualties or whatever. So that's the most important thing. And the main objective of this project is we have to give long-term, short-term recommendations also. How do we strengthen the health services, and all the things have to be given. So these are the three main objectives of our project. So these are some of the things actual. So when we did this one, how many life losses and other things have been calculated. And these are some damages actually, the past damages. When there was a cyclone fall in, happened in Orissa 2013, how many health centers was damaged? Like in Ganjam district, 155 health centers was damaged, you see. So the health center itself is damaged. So then, it becomes very difficult actually, okay. So these are some of the statistics. And then if you see the frequency of cyclones and others, automatically, you can compare with the neighboring states. If you see the IMD, this one say, the number of cyclone frequency is extremely high in Orissa when you compare with West Bengal or Andhra Pradesh and Tamil Nadu. So this is the most, the governing thing in our, this Orissa. And these are some of the frequencies actually. In every decade, if you calculate the frequencies, you can see how many cyclones, we can in the 10 years it is there. And if you see month-wise also, most of the cyclones in Orissa, so they occur in the month of June, July, August, September, October, the November. So these are and of course in May also some few are there. But this is a season for cyclones in Orissa. And you can see August month is the most, highest frequency you can see in August month itself. And these are some of the frequent, how many cyclones have occurred or whatever you can see in this Orissa state also. And the people have done like, using the flood, whenever there is a cyclone, flood also will happen, due to rains and then cyclones or some, people have tried to find out the vulnerability index also for this Orissa state, and all the districts they have classified actually. So like for example, so the red color say, so these are the districts in which have very high vulnerability itself, just the overall state, not the hospital buildings, just the states actually for cyclone and then this flood analysis. And then these are the states which have very less, the vulnerability basically for wind and cyclone itself. And of course, there is a flood, this one also. So this also is available. People have done some simulations and they have said, so these are the regions where you can see the flood frequency is extremely high and the inundation frequency is extremely high in these places also. So now what we did was, we have to do the whole hospital buildings. There are so many hospital buildings are there. And the time given to us was only, 1 year time was given to us to complete the work actually. But, we cannot complete, we can't do the entire things itself. So we have to do some, how do we proceed this one say? So we have to do this one. So like we have done some, background research, we have done GIS, we have done how many samples we can do, the accessibility, like you see what questionnaire I have to take it, the field evaluation, so what type of tests I have to do. Then as already I told these, the hospital buildings are not only structural, non-structural components also becomes important. So these interviews and disaster preparedness, we say whether the the doctors or the nurses, whether they are are knowledgeable how to handle things in a disaster, that also becomes very important. So we have to conduct interviews also of the doctors, nurses, then this functional group meetings we say. So this also we have to conduct at the community level. Then of course the structure analysis, this has to be done. Then workshop, and finally, we have to give these results and give it to the disaster management authority itself. So what happened was, during these projects, because non-structural also was important. So we have formed a group actually. So structures component I was taking care. Then we had a doctors and people coming from masters in hospital administration, actually MHM. So those students were also there. So it was a huge group act. And then we also have to have some GIS expert here. Then we also should have a person who works in the this app development and all other things also, the computer related things. So it was a huge group of some 10 to 15 people, which we did this work itself. So what we did was we have to first review we did. So what we said was we will take this IPHS guidelines, of this hospital thing. Then hospital safety index which is given by World Health Organization. Then there are, the WHO documents are there. We used all these things, the methodologies and others, to evaluate all the hospital buildings. And then we have also said which are the districts affected by cyclone, which are the districts affected by the flood actual. So these are the three districts, most affected by cyclone, and these are affected by the flood itself. So now, so these are the districts basically. You can see entire Orissa. So these are the districts which we have to model. We have to evaluate actually the hospitals in all these districts itself. So now, if you see the sample size, so there are basically, total. If I conclude, like community health centers, total 63 are there in these districts itself. Then primary health centers 252 are there. Then sub centers is 1,260 sub centers are there. So total we are having 1,575 the hospital buildings. We have to do the evaluations. Now, of course, some of them like 1660 located in flood prone region. Some of them are located in cyclone, and you can have a combination of both also. Now, these many hospital buildings, it's very difficult to do it in a very short duration of time actually. So what we did was in statistics, stratified sampling. We say you have to use select. You no need to do analysis for all the 1575. You select something like a stratified random sampling such that it represents the entire sample itself. So based on our stratified random sampling and so many analysis, we finally boiled down to 170, the hospital buildings. We will be able to do the complete analysis itself. In that 140, in that 34 are community health centers. Community health center means it's a big hospital actually. Then primary health centers little small. Then 68 sub centers have been selected here. So these are the community health centers which are in the Orissa, in these 10 states, which are prone to flood as well as cyclone actually. So these many are there total. So out of this one, after stratified sampling, we have selected these community health centers. So these are the community health centers where we have done our analysis actually. Okay, that is the vulnerability, repair strategy, all those things we have done only for this buildings itself. Now coming to the primary health centers, so these many centers are there. Okay, so the entire distributed in all these 10 or 11 districts itself. So now from this we have done stratified sampling. We have identified only these buildings itself. Actually, these are the hospitals. Okay, where we will be doing a detailed study itself. And these are the sub-centers actually. So many will be there, the sub-health centers. So we can't do for all the sub-centers. We did stratified random sampling, and these are the sub-health centers where we will be able to do the detailed, the analysis of the repair strategy, all the things we can do it for our Orissa. So this is how the first step was from the entire database. We have reduced our database because we will not be able to carry out, in detail for all these buildings itself. And now these are just the same thing only. I'm just showing this one. So these are the buildings where we have done the study: community health center, then the primary health center, and then these sub centers. So now we have divided, like into these analysis, structural components, then non-structural components, then emergency preparedness plan. Whenever there is emergency, say whether the nurse or the doctor or the community people actually, whether they are very well trained or whether they are aware of all those things becomes very important. Then we have to do not only the structural component, non-structural components, say architectural elements, medical facilities, lifeline facilities like emergency exit, fire system, electricity, water supply, medical gas, actually, okay, oxygen cylinders, then communication systems, whether these are all fine. So we have to take care of all these things, and then we will evaluate that the hospital. See, like a hospital, if structure is perfect, say, but if non-structural or the doctor is not there, there is no point actually. So we have to take care of all these things, and then we have to give a score itself. So we designed some type of rapid visual screening, we say. Okay. So rapid visual screening, we say, like, we have a questionnaire kind of thing actually. So like, for example, we say, have the hospital been exposed to significant, not seismic event, it is basically cyclone or, the flood thing in the last 30 years, if it is exposed, say, then we give high, medium marks kind of thing. Has the hospital suffered significant damage? So no damage means 0 marks, so medium marks, 16 marks, like that, columns regularly distributed, structure is regular in plan, elevation, foundations of stiffness are not, balconies are there, soft stories, then, so like this, we prepared our vulnerability, these type of a questionnaire actually. So, and then, this is for the structural component. When it comes to the non-structural components, say, like an electrical system, telecommunications are there, fuel tanks are there, gas cylinders are there, medical gas actually, okay. So all these things have been given the question, like air conditioning equipment is there, joints of piping are there, anchors, architectural elements, movable equipment like X-ray machine, whether it is a movable, the CT scan, all those things, radiology, windows, parapet walls, everything has been done. So now we have made a questionnaire based on all these things. And then organization, disaster preparedness, like an emergency generator is there. Suppose if there's a water tank, say, okay, because whenever there is a disaster, the pipelines may get choked, whether the water tank has a 3-day capacity or a 5-day capacity, medical gas, 15-day capacity, external circulation, emergency center is there, where the drugs are positioned actually, okay, the medical things are put up on elevation or where they are located, emergency surgery room is there, administrative procedures. So all these we have prepared a huge questionnaire actually for our rapid visual screening. So we have divided them into accessibility, and accessibility is very important for a hospital, whether ambulance can go there or not, two-wheeler, three-wheelers also becomes very important. So building infrastructure, critical systems, logistics, staff personnel, whether the doctors are really there, then operations and management. So all these things have to be taken care because it is a hospital building. Suppose if it was a residential building, so then you can just go for the building infrastructure itself and accessibility. But since it's a hospital building, all these things becomes very important in evaluating the the complete the structure itself. So we have prepared a questionnaire, and since here, as already I mentioned in Orissa, seismic, these earthquakes are not there. Only we are having cyclones and floods, and of course storm surge, inundation basically. So these are the most important. So we have devised a new rapid visual screening questionnaire actually, okay, which can take care about all these issues itself. So like for example, so how many external walls are there, thickness of the slab and height, then this one, Then building details, what's the age of the building, condition of the building, configuration, because it depends. If the zigzags, wind, it is very good actual. Okay. So then what is separation distance of the hospital from the surrounding building, what type of construction, roof actual. So when you're having this type of roof, means safety level will be low, average, high, we do all this kind of, any past structural damage is there, then site topography, where it has been located, the cyclone hazard, any elements are there, debris movement, building integrity, say condition of the construction material, secondary structural, this one, redundant method members are there or not, plinth actual. So this becomes very important. The flood level, whether the plinth is higher than or how it is linked to the flood level also, irregularities are there, you know. Then elevation, then condition of the systems actually, how the connections are there, because for wind, say the roof and the slab or roof or whatever, say how it is connected here, the width of roof projections, the parapet, this one, then water source, water supply, capacity of water storage, so all these electricity connections. So we have made a huge questionnaire kind of thing itself. Then these are like, alternate electricity, this becomes very important. Emergency lights are there or not, storm water drainage, and suppose if there is any storm water comes actually, whether there is any drainage system is there, sewage disposal, very important actually. Okay, so how the sewage is getting disposed, biomedical waste, it is a very important, the biomedical waste after surgery, how they are disposing, that's also very important. So all these details we have made a questionnaire. And these are like, architectural elements also, major damage is there, condition, safety of doors, is also very important. What is the distance of the opening, safety of windows and how the window looks like, of other elements, facility accessible, height of the parapet and condition of the parapet. So we have defined a questionnaire. So what happened was we defined a questionnaire, but then when you go to into practice, you will get new problems actually. So we have updated it. Is about like a dynamic kind of a questionnaire, which we prepared, and we developed apps, so that we have divided some 3 or 4 teams to say. They go to variety of the places and people will fill these questions and we will get the information also. So like you can see obstacles to damage, elements, then the internal walls, conditions, corrosion is a very huge issue. Then a truss roof, stairways, ramps, and the most important thing, signboards, solar panels, whether they have been anchored properly or not. Because if it's a cyclone, the wind speeds will be high, say. They will fly and then may cause damage also. AC units, wires, cables, porticos, towers, all those things. Lightning arrestor is also very important. The lightning arrestor also. So all these, and then safety of physical access, hospital access route, as already I mentioned, how much is a width, can ambulance pass through the thing also, entrance, then safety of drug storage system actually, where they are storing the drugs, then staff capacity, how much staff is there, whether the display list is available, staff members are trained. So all these things we have created a huge questionnaire actually. So we have given, so this is for the structural component, so based on our thing we have designed. Of course, these and this was almost for the first time. Generally, if you see the literature, this type of questionnaires will be available for seismic things actually. But in Orissa, as already I told you, there is no earthquake here, wind and cyclones. This was the most important. So these things should have been, these questions we developed basically, on our own. And then once we went to the field, so we modified and then came up with this nice questionnaire actually. So now based on that, now the first step is we have identified the which are the highest vulnerable buildings, so that we can define a repair strategy or retrofitting or whatever at a later stage. So these are some of the numbers actually. So if you see the accessibility, say, okay, so you can see of course accessibility is fine. So you can see in this ones there is one here in Ganjam, say, and then you can have more problems. You can see well fit, the accessibility. You can see these unpaved 8 feet road, say, okay, and you can see some of the unpaved access, whenever there is a rain, it will be huge problem actually. Okay, so this one. Then the building infrastructure, so we have CHC, PHCSC, so which are in high, means vulnerability is very high, it's the most dangerous actually. So you can see in Badrak 3 places actually, it is highly vulnerable. So we have identified all these, which are the hospitals which require immediate the repair strategy or whatever we are called. Then we have the building infrastructure, you can see, okay, the building envelope, windows, wall, roof and construction material. So if you see, we have identified, these are the very high PHCs, so many are there. You can say 12 PHCs, SCs, all those things are the sub centers. So we have identified all these hospital buildings which are which require immediate attention. So this is for rare events, building damage. So we have classified all of them nicely. And then the status of stormwater drainage. So then like this, we have given all the marks. You can see the whole of hospital buildings are full of corrosion actually. So these are most important thing which we have seen actually. Okay, the most thing is corrosion, and it is all chloride. So this is what we have observed actually. Okay, the chloride corrosion. Of course, the loads are all perfectly fine, but some places are there. So some hospitals, what they have done is, it was a primary health center because of pond. This has been constructed 30, 40 years back. Because of increase in the population, because if the population increases, you should have a construct a CHC also. What government has done is PHC itself, they have converted into a CHC, like additional something, they have put up one more floor or something. So they have done some alterations also. So that is how this has happened. So that also created some type of distress actually. And then in Orissa also you have huge temperature differences also. As already I showed you, the curling and other things of the slabs, that also we have seen in this many of these buildings also. So this we have identified the stormwater drainage and all other things also. Then another thing is the drug storage actually, or the biomedical waste also. You can see, so some hospital, this also is a very huge hazard actually. This is how they are dumping this biomedical waste. So some hospitals, they have a nice they have a pits are there where they dump here septic tanks and other things also. Some places they dump just on the the road itself. They will cause health hazard at a later stage. So we have got all these critical systems, everything in detail, the hospital structural component, non-structural components, then the staff, personnel, disaster preparedness, everything we have done for all the hospital buildings itself. So finally, so we have developed something like this actually. So we have developed even a website also, GIS based platform. So we give like this. You can see these are the indicators. Okay, the accessibility, most important. Then the building infrastructure, critical systems, logistics actually. Okay, then the staffing personnel, then operations and management. So we divide into this one, and we give these type of colors actually. So red means very high vulnerable and immediate attention actually. Blue means it is perfectly fine. Then yellow means it is like a moderate kind of thing. So you can see, so this hospital say, so building structure is fine, but structural elements, they are moderate vulnerable here. But if you see logistics, they are having high vulnerable also. So what we have done is we have found out key findings also, like structural, non-structural. You can see elements in the surrounding trees that can hinder. We have given all the details actually. Then what are the recommendations also? Short term, then long term. So we have seen a lot of hairline cracks here. Then minor repairs are required. And biomedical waste management, drug should be kept. So we have given all these details for each and every hospital building itself. So these for another, I think the primary health center. You can see, so here this primary health center building is perfectly fine. Actually, you can see the building is perfectly fine. It you have some small things are there, but it is fine. But you can see logistics, staffing personnel, operations management. It is zero actually. They have no idea how to handle things when there is a disaster also. So so we have classified them based on all these things itself. And this is one more, I think, sub-center. It is a high, you can see the vulnerability. Layout is fine, but structural elements and others, huge cracks are there actually. Okay, damages, shear cracks are there, structural cracks are there, and even the joints, beam column joints, we have issues. Then the slab, so all those things we have been, major cracks are there. You can see walls, columns, beams full of corrosion actually. Okay, the concrete spalling, delamination, everything we have found out in these hospitals itself. So this is also another building I'm showing you. So like that, we have got all the the details. Like you can see huge corrosion. This is also hospital building. The huge corrosion is also chloride induced corrosion we have seen, and some hospitals converted into higher this one. So the loads also got changed actually. Okay, so that also, and then this the hospital was constructed 40 years back. Then 20 years back, they have done the alterations. They have converted the old material, new materials. They got disintegrated also. So all these issues you can identify in this hospital building. So then what we did was we even created a website actually, okay? And the website, the link and everything has been given to the Orissa State Disaster Management Authority. So they are having this one. So if they can click, say, if they go to this website and click any this Adhampur or whatever PHC block, you will get nicely these photographs, everything we have attached actually, like condition of the road, and we give color also. So red means, vulnerability is high. That is what the priority should be. Then blue means, it is perfectly fine. Then we have a moderate things also. So this nicely, we created for this Orissa also. And finally, we have classified this vulnerability also. Like, we are giving a score to each hospital building. So based on, I have told you, we have given the marks, right? Some 0 marks, 8 marks, 16 marks, or 4 marks, or 8 marks. Based on all the classifications, we have even calculated the safety index factor. So these our World Health Organization gives. So structural portion, non-structural portion, you take it. And finally, if it lies between 0 to 0.35, so it is a classification C. That means urgent, the vulnerability is very low, very high. That means this one. And A means, the hospital will function in the case of a disaster. So this we have computed for all the hospital. So you can see for community health centers, so you can see that, 39% actually of whatever we have done, they are at medium risk, and 61% is at high risk actually. Okay, then PHCs means, 21% are at high risk, only 3% are at low risk. Most of the things are at medium risk, but community health centers, high risk hospitals are very high actually. So organizational index, as already I told you, structural components, all those things we have done. And finally, these are the structural index actually. Okay. So low, medium, high, we have classified here, and we got all the numbers actually. How many, like, structural component, non-structural component, organizational, this one. Then we combine all of them and give finally one type of a rating for all these hospitals itself. So now once we have identified, so which are the most, the dangerous, as I already mentioned, we have identified the hospitals which require immediate attention. So we have also given these type of methods actually, how they should repair the structure actually. Okay. So as already I told you, most of the structures we have done all kinds of tests, like half cell potential, all kinds of things to identify the causes, and it took a lot of time. So we have also done some mistakes actually. So some cracks was there, we told it is due to some corrosion based cracks. But when we did the test, there was no corrosion. It was some flexural crack or a shear crack. So many issues are there. It is not that straightforward. So we did all the studies, and then, if it is a corrosion based cell, how we have to do the section enlargement, the loading, like as already I told you, the existing hospitals is being converted to a community health center, big hospital. So they want to put one more floor, or, that has created the distress actually. So we have said, like, how do we section enlargement, whatever repair strategies. So because in repair, the most important thing is, you have to identify the cause, and then you have to evaluate actually how much repair or how much damage has been happened. If you know these two, the strategies are very easy actually. Based on the local available material, local skill, you can easily, repair the structure itself. So these are the standard things, because we have identified what is the cause accurately. So automatically you can find, vertical load, how to do this one, you put this thing, and then you can, this becomes very straightforward. So there were some places, say, you can put some steel bar, like a passive strengthening, for the slab or for the beam, and the bonding epoxy adhesives, additional strength you can do. So this we have recommended basically, and we have found out the causes also. Mostly the things are chloride induced corrosion. Then other most important thing is this load actually, essentially. Okay, the loads was the most important, because they've altered, and these buildings have been constructed some 40 to 50 years back actually. Okay, the codes also got changed, and so many issues are there. So all those things we have nicely classified, and we have also suggested actually what type of the repair strategy you have to follow for these beams, columns, slabs, and other things also. So this also we said, reinforced this concrete ferro cement laminates, this FRPs and other things also we said. And these are shotcrete or whatever, strengthening FRP, this one, so I can use these things. So we have suggested many of these techniques also. And some buildings, of course, I think that the PWD department or whatever, they have adopted some of these things, and I think they would have repaired. After that, we have not heard anything from them. So some hospital buildings, they have repaired and then, rehabilitated some of these buildings also. So these are some of the steps we have given them, how to damage, how to remove the damaged portion, anti-corrosive coating, to do for corrosion index and epoxy bond coat and other things. These are all straightforward tests actually, because we have identified the causes and evaluation. So these becomes strategies we have given them actually. And then they also wanted, we have also provided them, how do we construct, a new buildings, like simple masonry based, they don't want to go for RCC, some cheap available materials. We have given, like how to construct a small, these are some pictorial things itself, like it's lintel band, sill band, so foundation, plinth, like, and most of these structures, they are not constructed by, some masons are there, that person also should be able to understand. So we have given these type of graphical, nice interpretations actually. So that we have given like where should be the toilet, inpatient room, doctor's room, how, like, small sub-center they want to do, so this one. And then tomorrow if they want to extend it, how to extend the small building itself. So these are something you extend for a public health center, the reinforcement, how it has to be. So these details also we have provided to the government, the PWD people also. Okay. So some of these things, they have adopted and you followed. So they have repaired, I think, one or two hospital buildings, they would have repaired also. So the entire reports has been submitted to the Odisha State Disaster Management Authority and even, this UNICEF, this one. Okay. So this completes my, the Odisha health buildings. Now I will just show you quickly, this is a Kedarnath temple actually. So this, how to repair a heritage structure. So this is another big challenge. So this repair is entirely different actually. RCC and others are very easy, but heritage structure is extremely challenging because we don't know anything, at least for RCC structure hospitals, we had even the design drawings and others also we had that old, the blueprints and others. But heritage structure, this structure would have been constructed, 1,000 years old. We don't know anything, the design we don't know, the drawings we don't know, what is inside also nobody knows actually. And if the structure has shown, the damages, cracks and other things, how do you repair is a big, a challenge actually. So heritage structures, they pose entirely, different challenges also. And this project came to us after this 2000 that floods happened, the Kerala temple got damaged. So, and here also the most important thing was one, I think the government gave this thing to one agency or one private company. So they did the testing, non-destructive testing actually. So that's what we call MASW. That's for the foundation actually. So what this company did was, they have tested the foundation for this temple, and then they said that foundation depth is some 3 meter to 4 meter or something. So that report showed that the foundation has full of cracks actually, and they said that, this temple may collapse or if the foundation is under huge distress. So the ASI, Archaeological Survey of India, the government was worried, so this work was given to us, and when we did the test once again actually, and we found out, and I will show you that there are no foundation cracks, only some foundation blocks have been slightly interchanged, and due to that this things came up actually. Okay. So I will just show you some interesting details. I think most of you may be knowing this Kedarnath is located in this Uttarakhand area, and this is located in the seismic gap. We said this is the most important thing in Himalayas is you can have earthquakes of magnitude 8.5, 8 also will occur near this temple. So this is one old photograph actually, okay, of the Kedarnath temple. I think somewhere around 1900 or something, they have taken this photograph. So anyway, so this Kedarnath Valley, sir. So in 2013, huge floods came. You can see. So these floods was there here, and this is a temple. You can see here. Okay. So that full boulder started rolling from the top, and they have hit the temple, and the impacts was essential. So the temple was damaged due to impact of boulders. So the government, and you know the details. So this Kedarnath is located here. So these are the two huge glaciers actually. Okay, so that cloud outburst of this Charabari, that lake got this one. So automatically, you can see the water gushed and then boulder rolling, and this temple was damaged due to impact actually. Okay. So these are some of the details about the Kedarnath. I think it was, I think this was built around 1000 AD. We don't know the exact dates, but this was the thing. And then some theory says that it is a temple built by Adi Shankaracharya, but there are some people say that it was Adi Shankaracharya. This was not built by Shankaracharya. Some other, there are some things are there. And then another most important thing was from 1300 to 1800 AD, so for 500 years actually, almost. So this temple was buried in snow itself. It was located in the glacier itself, and it was not accessible to the human beings itself. So Wadia Institute of Geologists, they have done this ligonometric dating. If you go to Kedarnath temple, the walls will have something like yellow color actual. So this glacial formation it indicates. So they say that around continuing up to 1748, around some 1800, the temple started. The glaciers went back, so the temple started. They became visible actually. So then slowly, so people started worshipping this one. And generally, if you see the history, some people have reported also in 1803 there was an earthquake actually. So this temple was partly damaged. Then the restoration period also happened. You can see in 1815, 1842, this temple was repaired actually by some people who did it. We don't know the details, but just we know the things that this temple has been repaired or retrofitted during this times itself. And there are a lot of similar temples are there near Kedarnath. So the architecture is same. If you go to Uttaramukhimad temples, Uttarkashi, other temples also, you can see the same type of architecture, something they call as Nagara type of architecture, which is widely used in the North India, that is essentially in the Uttarakhand. This is our Kedarnath temple itself. And as already I mentioned, this temple is located in the the Himalayas. So all these pink lines are all the faults actually. So there you can have 8 magnitude huge earthquakes actually. There was a 1999, 1991 6.8 Uttarakashi was there. 1999 Chamoli earthquake also occurred 6.1, very close to the Kedarnath temple itself. Of course, there was no damage in this temple itself. So this temple said, but the unfortunate thing is this temple did not get damaged with earthquake, but it got damaged due to these impacts actually from the boulders, during this one. But the temple survived. The reason was it is built on a man-made plinth. Actually, you can see these are the dimensions: 50 meters, 30 meters the temple complex, 8 meters is this one, and 20 meters is the height of that amlaka, that shikara or whatever they say here. And you can see the whole walls. You can see the backside wall. These are huge boulders. So they have hit the temple actually. So due to this impact, many of these walls got shattered kind of thing itself. And one you can see that, I think you would have seen in the news also, there was one huge boulder was behind. It just stood up, and this protected even the temple. Due to the further impacts itself. So you can see this wall of this one side of the temple. It got completely damaged by the impacts. So huge boulders, they came during the flood, and they impacted the temple. You can see how much the walls has been displaced. These rocks have been displaced during this impact, and you can see huge boulders was there. So when this project was given to us, the Archaeological Survey of India, they wanted to know us, if they remove all these boulders, whether this temple will stand or it will collapse actually. And there was another report, as already mentioned. They said that the foundation said there's huge cracks, and if you remove, the temple gopura will collapse like that. The report was there from their non-destructive testing techniques actually. So what we did was, we did this test once again and then checked this one. So these are the details of the plan of the temple itself. You can see. And the temple, the walls are of 2 meter, 2 to 2.25 meter thick actually, the walls. And the most important thing, what we found out was this information was not known before. So this is like a two dry stack masonry, this one, and multi-leaf construction. So you can see one wall is here actually, another wall is also here, and these two walls, it is filled with this random rubble masonry itself actually. So this is like a two leaf this one, and in the middle you are having a random rubble masonry here. The random rubble things are there. So this what happened was this used to give a good insulation actually, and then to the for the people who are sitting inside the temple, it will be warm and other things are there. So now what happened during this flood, because water gushed in and this happened, so these random rubble things, which are in between these walls, so it just got washed away actually with the flood itself. And then what happened was the insulation, then all those things got disappeared. Like if you are seeing in the Garbhagriha cell, previously if somebody is chanting outside, you can't hear that sound, or outside sound doesn't come inside. But because the random rubble got washed away, so you can have this sound, and other issues was coming up. So this also we found out from our tests. So we just, wherever a crack was there, we took even our endoscopic cameras actually, like small cameras. So we just put it inside and saw that there was a huge random rubble masonry which was which washed away inside, and it is not like one wall, it is basically two walls actually which are there filled with this random rubble masonry. So this was very important observation, which we made, which people have not reported in the past itself. And as already I told you, the most important thing was the foundation. Due to this impact, whether the foundation had huge cracks or what is the depth of the foundation of this temple was not known actually. So that other report was very, the problem was there. So we conducted all these non-destructive testing actually. It is same as, multi-channel analysis of surface waves, like you hit with a, impact say, and then we put geophones, and then we try to find out the velocities actually. So where whatever things are, we will easily get from this graph. So you can see, so these are all our geophones, so you can see the temple in 2014. So we put up a setup and we hit with the hammer and we get all the recordings actually. And then we do this analysis, the inversion we have done on the front of the temple, this side of the temple, this side of the temple, and all the four sides actually. And we get these type of graphs, and then we'll get this type of figures itself actually. Okay, so you can see this is the foundation. You can easily, this is a foundation of this one, and you can easily find out at a depth 30 meters, say, whether there are any cracks or something. So we can easily get from this the results itself. But there's a more challenge, it is very challenging, to interpret this results itself. And we have also done inside the temple also, like in the Garbhagriha, we have put the geophones. You can see we have done this at the night time, and we have got once again the foundation. So what we found was a temple depth. So you can see is more or less 3 meters. You can see here up to after 3 meters, you can see different type of this one. So we got the foundation depth also, and there was no cracks actually. It was all perfectly fine. So this foundation means it was perfectly fine, and there was some settlements towards other side. So we have documented all these numbers itself. Now what we did was, because this temple is located in a highly seismic zone, we standard, we wanted to find out vulnerability or how much, what will be the ground motions which can damage the temple also. This also we just wanted to find out. So we did, these are the standard techniques, pushover analysis, nonlinear dynamic analysis, there are standard softwares are there. You can do the analysis. And of course, we have done the uncertainties, the metal properties. What is elastic modulus of the stone for the Kedarnath, friction angle, compressive strength, wall thickness, and the peak ground acceleration. So all these uncertainties we considered here, and we generated some 50 sets, some random simulations we have done. And to model the temples, we used this, this method of this element, and we used this is our failure model, the cracking, shearing, crushing material model, which is available in the softwares, and we use this curved shell elements, okay, that in plane, out of plane, all those things, and we constructed a finite element model for the Kedarnath temple itself. And the problem here is, generally the Kedarnath is located at high elevation, say. We have to simulate for 8 magnitudes. We don't have the data. Topography also plays a major role, actually. So we modeled all these things, and we simulated for hypothetical earthquakes. Okay, so all the topography amplification modeling we have done, and we have built huge computation models actually. Okay, as already I mentioned you, this is my main primary area of research. So to simulate these ground motions, and this is a Kedarnath, we modeled the exact thing itself in finite element, and we simulated a lot of time histories actually. Okay, so which we have done in our supercomputer, which is available at our IIT. And we have got all these time histories actually for 7, 7.58, 8.5 occurs. So what will be the ground vibration actually, the time acceleration time history. And then this was given as input to the temple finite element model, and to see that whether the temple will withstand or whether it will collapse, or what type of failure mechanisms you will see in the temple section. So we have done these simulations, the central seismic gap, and these are some time histories actually, which we have simulated from our models. So this is the finite element model for the temple act. That curved, as I've shown you, curved shell element has been used. So this is our temple, and this was we have got the natural frequencies also. So this is the first time whatever study we have done for Himalayan temples. Say most of the many people nobody has reported the frequency. What's the natural frequency of the Kedarnath temples? So we found out the first natural frequency is around 10 hertz actually, very high, because it's a masonry rock structure, right? Around 9.9 hertz is the first natural frequency, and here is a mode actually, X direction, Z direction. Second natural frequency is 10.1. You can see 17.6, 18.5. These are the natural frequencies, and these are the mode shapes, like mode 1, then mode 4, mode 9, then you can see mode 2, mode 3, mode 5, mode 8, translations in transverse direction, other directions, how the mode shapes are there. This we found out. Then we have done the modal analysis also. Then we have done the pushover analysis also. How this temple, it is like a static, this one also, how it is going to break. You can see the diagonal shear cracks will come, and these how the sliding failure will come. So we have identified all the failure the phenomena also, and the dynamic analysis also has been done. And these are the displacement contours at the time of failure. For PGA 1G, how much will be the displacements and the principal stresses and all those things we have found out actually. Okay. So and then this is how the temple looks like. So if it's a PG of 1G say, so you can see the temple displacement. It will oscillate for some time, then obviously it collapses actually. Now for a PG of 0.2G, so the temple will not collapse. You will see some small drift, but still it goes away. But for 1G, say the temple gives up and it will just collapse actually. Failure mechanism will get formed. So this was our what we said. So the temple was found safe, for ground motions below 0.35 G. So the temple is perfectly safe actually, irrespective of whatever this one. Now, if you PG of 0.8 G, say the structure did not fail, if you take high elastic modulus and friction angle, if you can repair those issues or whatever, so 0.8 G also it can survive. And so this failed and non-failed we have got, and finally our conclusion was, the shear wave velocities in the top 20 meters from our foundation testing indicate debris, loose soil, no significant features actually. So this was the most important observation which we gave to the, the ASI, and based on our recommendations, so the stones have been removed and the repair work has been done actually, okay, around 3 meters. Then, of course, on settlement, we have said eastern side of the temple. So this also has, I think, I don't know about this one, site amplification we reported. And regarding the structures, so what we said was the shikara, that is the main thing, is the most vulnerable. And our conclusion says is the potential formation, say, is beyond 0.4 G actually, can be expected. So what we said was, if the PG at this temple site, say, if it exceeds 0.4 G, definitely this temple is going to, the shikara is going to collapse also. So dynamic analysis and all other, separation of walls, mild, moderate has been studied, and elastic is a significant influence. And we got all these numbers itself actually. And not only this one, one can use this as a the inverse problem also. See, like this temple is standing for the last 1,000 years, say, and the temple to collapse, if it is a 0.4 G, is required to collapse this temple. So you can say that in the last 1,000 years, this much of PG has not been observed also. Like this temple has not been experienced in this region also. This also we can make a conclusion, say that this region has not experienced this much high accelerations actually. But Badrinath temple, if you see, that has been damaged and lot of historical records are there, maybe that place would have felt more peak ground accelerations also. And then after this, we have given them a repair strategy actually. Okay, so because the repair strategy was, as already I told you, the random rubble masonry washed away actually. So we have given them, like, you fill the gaps with the random rubble masonry, and now I think still that work is keep on going on. And now what we've done is we have put sensors also in the entire temple also. If there is any distress, we will able to record it, and then we will use it for further further repair or rehabilitation for this temple itself. So anyway, I think I will stop here. So most of the things I've covered here. So if you want to know more about the details, you can go in papers and whatever ResearchGate website is there. Okay, so I've uploaded all my papers, publications like Kedarnath and whatever I've discussed here. So they're available in my ResearchGate website also. And of course, I have whatever lectures I have. So my class, because of Corona, so everything is online. So I've uploaded in the website also. If any of you are interested, like steel design and others, these lectures are also available actually. So finally, whatever I have shown you today, I think, that Orissa projects, it has been done in collaboration with this Taru private leading edge, okay? And some one or two doctors also was a part of the team. So we have done, it is like a teamwork basically, okay? And this Kedarnath works, this also was done by my colleague Arun Meenan is there, Tamali, Kavita, all these are my students actually, okay? So they helped to do this work, and then we got this results itself.